Version management is the process of keeping track of different versions of software components or configuration items and the systems in which these components are used. Without a systematic process, management of software artifacts boils down to using file names to manage versions, zipping up files and emailing them to coworkers. In short, a Stone Age nightmare. Today we will trace the long history of version control systems and examine their important features. We will talk about architectures, taking the JIT version control system as a case study. In order to understand the concept of version tracking, we need to understand what are code lines and baselines and what is involved in their management. A code line is a sequence of versions of source code with later versions in the sequence derived from earlier versions. Code lines normally apply to components of systems so that there are different versions of each component. A baseline is a definition of a specific system and specifies the component versions that are included in the system, plus a specification of the libraries used, configuration files, etc. Baselines are controlled, which means that the versions of the components making up the system cannot be changed. It also means that it is always possible to recreate a baseline from its constituent components. Baselines are important because you often have to recreate a specific version of a complete system. For example, a software that was delivered to a specific customer may need to be fixed if that customer reports bugs in their system. A mainline consists of a sequence of baselines representing different versions of a system. Simply put, version control systems are specialized systems that record changes to a set of files over time, so that you can recall specific versions later. Over the years, these systems have evolved significantly from centralized repository-based scripts like CVS in the late 70s and 80s to products like Subversion, also known as SVN, that directly integrate with many development tools. More recently, we are seeing increasing popularity of distributed, highly scalable products like JIT in the 2000s. In these tools, there is support for assignment of unique identifiers and attributes to submitted components to uniquely identify each version. While different version control systems differ slightly in the features they provide, the architecture can somewhat be generalized. To support independent development without interference, version control systems use the concept of a project repository. We also sometimes dub this as repo, and a private workspace. The repo is essentially a big database in which the master version of all components are stored together with their versions and create baselines for system building. In the old days, the storage management was the most important function of a version management system because disk space was very expensive. So when we changed a file, we did not want to create a copy of the old file, but only store the delta or difference between the old file and the new file. Storage is now less important because of cheaper storage devices. When modifying components, developers copy or check out these from the repository into their workspace and work on these copies. This is somewhat similar to how Dropbox informs you about the changes your collaborator has made to a file. When they have finished their changes, the changed components are returned or checked in other words, to the repository. The version control system ensures that the changes made by two users working simultaneously on the same component do not interfere. In this example, Alice can check out versions A 1.0, B 1.0, and C 1.0, create A 1.1, B 1.1, and C 1.1, and check them back in. Whereas Bob does the same with X, Y, and C. Now, since both work on C 1.0 simultaneously, the system ensures that individual copies are checked back in, which can be systematically merged later on. There are two types of modern version control systems. There are centralized systems, where there is a single master repo that maintains all versions of the software components that are being developed. Subversion is a widely used example of a centralized version control system. Distributed systems, where multiple versions of the component repository exist at the same time, is becoming more popular. JIT is a widely used example of a distributed version control system. In this case, a master repository is created on a server that maintains the code produced by the development team. Instead of checking out the files that they need, a developer creates a clone of the project repo that is downloaded and installed on their computer. Developers work on the files required and maintain the new versions of their private repository on their own computer. When changes are done, they commit these changes and update their private server repository. They may then push these changes to the project repository. Distributed version control provides some inherent benefits over a pure centralized approach. First, it provides a backup mechanism in case the master repo gets corrupted. Work can still continue and the project repo can be restored from local copies. It also allows for offline working, so that developers can commit changes if they do not have a network connection. Third, developers can compile and test the entire system on their local machines and test the changes that they have made. Finally, it is essential for open source development, whereby several people may be working simultaneously on the same system without any central coordination. Developers maintain a public server repository to which they push new versions of the components that they have changed. And it is then up to the open source system manager to decide when to pull these changes into a definite system. Another important concept in version control is that of branching. Imagine for a moment that I am giving this lecture in a foreign country, and so I remove all the English words in my files and replace them with the foreign language, which is version 2.1.2 in this case. At the same time, I improve some of my old slides as version 2.3. And so I have to branch or fork, so to speak, my path of development. But then suppose I come to a new semester and I say that the examples I use in the foreign language are very good, and so I want to have the possibility to merge the two branches.